FDM works by melting and extruding thermoplastic filament layer by layer to build up a 3D object. SLA works in a very similar fashion, except it's using a liquid resin, and it dunks the build plate in and uses a UV light to cure that layer. This process is more precise and allows you to achieve much finer details compared to FDM. SLA printed parts are also isotropic, and this means that the layers are chemically bonded together, which results in parts that are equal in strength in all directions. When it comes to accuracy and resolution, SLA generally has the upper hand. The Form 4 has a 50 micron pixel size in the XY plane, and this can go as low as 25 microns in the Z. On the other hand, the standard nozzle size on an FDM printer is about 400 microns, so you can imagine the difference in quality and accuracy. The biggest limitations of FDM when printing fine details in small parts are the visible layer lines. While it's not a problem for prototyping, if you're looking to create end-use parts, then the finish of an SLA print is far cleaner and can have much smaller intricate details. Both technologies have a wide range of materials available. FDM uses thermoplastics such as PLA, PETG and ABS, whereas SLA printers use resins with specific mechanical properties. For example, you can get durable resin for parts which are going to be experiencing repeated wear and tear, or tough resins for parts that need to be really strong. Formlabs also have some specific materials such as silicon 40A and high temp resin which can only be achieved using SLA. Post-processing for FDM usually involves removing the supports and cleaning up any marks left from them. You might choose to sand down any visible layer lines and then paint the part as well. SLA, on the other hand, requires washing the part in isopropyl alcohol to remove any uncured resin and then curing it under a UV light. Post-processing an SLA print is generally a little bit more involved, but results in far smoother finish. To achieve the same level of finish from an FDM part would be considerably more work. FDM printers and their materials are typically more affordable upfront, which makes them a great option for hobbyists and small businesses just getting started. However, when it comes to speed, SLA printers can really shine, especially with Formlabs' new LFD technology in the Form 4. This technology uses a screen that blocks UV LED array below, allowing it to expose each layer instantaneously. What this means in practice is that the time it takes to print one part versus the time it takes to print 10 parts is almost the same. This makes the time per part incredibly fast when you're printing multiple parts at once. So while the initial cost might be higher with SLA, the time savings can be a huge advantage, especially for businesses that need to produce multiple parts quickly. If you're a business using a bamboo printer currently, then upgrading to a Form 4 could be a game changer for you if you need higher precision and better surface finish. SLA is ideal not only for prototyping, but for also creating high quality end-use parts, and it's the best choice for any industry where fine details and surfaces are crucial. The two technologies can also be used hand in hand, as you can create prototypes on the bamboo and then create your final end-use parts using SLA. I think that the future of 3D printing is looking really exciting. We're seeing quick advancements in materials, faster print speeds, and ever-increasing build volumes. SLA will continue to be a key player, especially in industries that demand high precision and customization. I also think that we'll see more integration of 3D printing into traditional manufacturing processes, making it a standard tool in many industries.